Hey there, everyone, and welcome back to More Math with me, Mr. Oldenburg. We're going to get close to the end of this chapter now with writing numerical expressions. That's right. So far, we've been looking at them, evaluating them. Now we're going to look at words, and we're going to actually write the expression in numerical form. A lot of fun over here. Big things we're going to have to worry about, making sure we're paying attention to the semantics of the words being put down. Again, like the other lessons for this one, hang back for the do now of the day after this is over, so that way you can go over quite an extensive evaluation using both brackets and braces in it. All right? So without further ado, let's get this started. All right. A baker packages 12 cupcakes to a box. Not a real baker's dozen. Sean orders 5 boxes for his sister's graduation party and 3.5 boxes for the variety show party. He's a very generous person. Write an expression that shows the calculations you could use to find the number of cupcakes Sean orders. So all we want to know is how many cupcakes he ordered. We do not need to solve this, or evaluate it. Evaluate, use the right term. Because they didn't ask us to. They just said write an expression. So, what do we know? Things we know. There are 12 cupcakes in every box. I also know that there are 5 boxes for the graduation. Well, if I multiplied the 12 by the 5 boxes, I know that I'm going to get how many cupcakes they used at graduation. I put it in parentheses because I want to keep it away from everything else. It's a separate operation. I also know at the variety show, he had 3.5 boxes, and there's 12 cupcakes in each. Now, if I want to know the total number of cupcakes, I could add those two values together. The next question that I didn't put up here, but we talked about it in class, was they asked to show it another way. So, and they asked you to solve it. Let's talk about that. Another way I could have done this. Some of you decided to take these two. Oh, wrong number. All right. Some of you decided to take this one and just switch them. And yeah, that's a different property, so it looks different. Some of you switched the insides, it's all like the commutative property. But another way we could have solved this was to combine similar things. What's similar? How about the boxes? How many cupcakes are in a box? 12. Isn't it safe to say then that if there's 12 cupcakes in every box, I could add up how many boxes I have and then multiply it by the 12 cupcakes? And the answer is sure. The other thing I wanted to point out, actually 2 things I want to point out. One is that it doesn't matter if the 12 is in front or the 12 is in back, because you're going to get the same thing. But what does matter is that I have parentheses around the boxes. Because of addition, if we think about order of operations, we have, come on, S. Oh boy, I'm too close to the edge. There we go. If we think about the order of operations, I have to do all multiplication before addition, right? So, if I do not have these parentheses, that would tell me I'd have to do 12 times 5 first. And that's not very good, because then I just add 3.5 boxes to how many cupcakes I have. Bad news there. So the parentheses say you need to do this first. And you're going to notice that a lot of problems don't even need an extra set of parentheses. I put them anyway because I like to know what goes first. They don't hurt anything. So to speed this along, you're going to get 8.5 times 12. And then one thing you need to remember, and this is good review, so I'll do it. How to multiply by decimals. First, ignore the decimal, multiply like normal. 10, 6, placeholder. 8 times 2 is 16, 9. And when you add, you're going to get what looks like 1,020. But it's not. It's not, because we have a decimal. So I need to count from the right how many place values over I need to move. 1. So in my answer, 1 place a decimal. There are 102 cupcakes in all those boxes. All right, loved this. So the school auditorium has 546 seats in the main floor, another 120 in the balcony. All right? Sounds like I'm going to be able to combine stuff. Every seat is filled for all variety show performances. That is a huge bit of information. Every seat filled. So there are no blank seats. I will use these numbers each time. And at all performances. That's a good thing because if I look at my flyer, there are 4 performances. They want me to write an expression to show how I could solve it. Well, what do I know? I know that there are a total amount of seats. So the first thing I might do is add up all the seats, both in the main floor and in the balcony. And I put parentheses around it because the next thing I have to do is multiply that by how many performances there were. 4. If I didn't put those parentheses, I might have 4 times 102 first. And that's not good because that's going to give me all the balcony seats, but only 1 performance of the main. Not good. So, parentheses matter. This says, hey, add up and find out how many total seats there are in every performance, and then multiply it. Now, that's going to lead into this second question where 2 students wrote different expressions. Martin's is pretty good because he's saying there's 4 performances times the main, and then he adds 4 performances times the balcony. And that's valid because he did all 4 performances for each section. However, Ashley, she totally messed up because she said 4 times the main plus 1 show at the balcony. Not cool. She needed to have how many seats are in all times 4. And then it looks just like Mr. O's. Now what's cool though is I could have even taken this one step further. I want to throw some braces in this guy. No, I'm sorry, I'm going to throw some brackets in this guy. I also see some other information. I see tickets of $4.50 each, right? I could even ask, hey, how much money did they raise over all the performances? Well, now I can close in how many total tickets were sold and multiply that by the cost of each ticket. And then that would tell me how much was raised in all. So step 1 was to find how many total seats in one performance. Step 2 was how many seats in all performances. And step 3, how much did they raise in all the seats? Awesome, right? I know. Here we go. Why do some numerical expressions contain parentheses? Well, because in the order of operations, you want to make sure that you're combining the right terms first. There might be, and like we said in this example over here, if I don't, oh boy, I need to add before I multiply. But according to order of operations, I would multiply before adding. That's why we need parentheses, because that addition needs to happen before multiplication. Show how to use a property to write an equivalent expression for that. I love this question. So, one thing we fooled around in class with was, all right, well, let's just do this. Right? Commutative property. Or, how about this? Commutative property, right? And then I got fancy on you, and about 3 other kids got this as well. We did the distributive property, because all this is saying is 9 times whatever this total is, which is really 9 times 7 plus 9 times 44. So you could have done this, and then combine them. Totally valid. Erasing music, trying to do it really fast. Mostly because I got to pick you guys up from fine arts in a few minutes. All right. So, the next examples are just going to give me words. And then, well, actually they give me some numbers too, but mostly words. And what they're going to ask me to do is they're going to ask me to write the expression that it's showing. So, here it says add, and I love these. Sometimes they don't get any more specific than literally what it's supposed to be. And all I can tell you is you want to pay attention to what's being said. Read it carefully. Read it more than once if you have to. This says add 8 and 7 and then multiply by 2. So and then means it's going to happen after that. So the first thing I'll do is I'll write the end in mind. Then I'm going to add 8 and 7. You're going to notice that I picked the other thing. That always looks like the pointer because they give you this as the pointer. You're going to notice I put parentheses around the 8 and 7 because in order of operations, once again, multiplication and division would come before addition and subtraction. Same problem. So I would have to be careful because I would have done 7 times 2 first without these parentheses. These parentheses say, hey, no, even though that's addition, you're going to do it first because parentheses happen before the rest. Find triple the difference, keyword for subtraction, between these two numbers. So first I get these two numbers and I find the difference. And then I multiply it by 3. But I have to make sure that I have my parentheses because, again, multiplication would have come before subtraction. So stick some parentheses around it. Multiply 4 times 7/8 and then add 12. So 4 times 7/8 and then add 12. Now, this problem does not need parentheses because I have to do the multiplication before addition anyway. However, I put it anyway. I like to know what I'm doing first, and that calls to me more than, oh God, I'm going to go all Moana. It calls me. Have fun singing that. I'm going to do this anyway because this tells me, you know what? Hey, big shiny headlights. You know what? You're going to do this first. It's in parentheses. And a lot of kids usually mess up a multiplication and addition sign because they're similar. So even though you don't need the parentheses, I always put them anyway because it doesn't hurt anything. If anything, it just helps you. Finally, add 49 to, well, that means that's happening at the end, the quotient, keyword for division, of 125 and 5. Again, I don't need the parentheses, but I'm going to place them. All right. Add 91, 129, and 16, and then divide by 44. And then divide by 44. Do it at the end. Addition usually happens after division, so I'm going to throw some parentheses up there. Whoops, I literally copied. There should be a plus sign. Let's just make that a really ugly plus sign. Really ugly plus sign. There we go. Shouldn't really call it a plus sign either. Let's go down here. Subtract 55 from, okay, from something. The sum of 234 and 8. Again, don't need the parentheses. I'm going to put them anyway because it says get this from what I do to this. So do this. Show everyone you're going to do it. Find 8.5 times the difference, that's subtraction, between 77 and 13. The difference of 77 and 13 times 8.5. And then the final one says, well, it's not the final, but the final one up here. Multiply 2/3 by 42, and then multiply that by 10. Even though you don't need parentheses, stick them down. All right, now the last question. Write an expression to show the calculation to determine the total area of the rectangles. First of all, area, length times width. Length, width. So, all three are rectangles, and I know I would do 18 times 22. Then I look at the second one. Oh, and the third one. They're all the same. So do 1, let me get my pointer, figure out 1, but multiply it by 3, so you get it as if it happened 3 times. And if you didn't see it that way, you also could have done this. And just make sure you have your parentheses because you have an addition sign. Lastly, let's do the do now. Gotta copy it from the board. All right, I got 5 minutes. I'm good. Killing it. And I caught a bunch of you here today because a lot of you thought the answer was 60 and it was really 240. So here we go. Parentheses first. So, brackets, let me get my pointer. Braces, brackets, parentheses. You always do the innermost first. So 20 minus 6 is 14. Then I copy the rest of the problem again. You must show every step when doing this, guys, because otherwise who's ever grading isn't going to know what you did. All right? Don't do things in a single line. Keep funneling it down. The next set of parentheses are the braces. 14 plus 1 is 15 times 8 divided by half. Then 8 times 15 is 120 divided by 1/2. And this is where you guys screwed up because a lot of you said, hey, I know what half of 120 is. Half of 120 is 60. But they didn't ask for what 120, 1/2 of 120 is. Because if they said of, that would imply that this sign was multiplication. Oh yeah. Oops. That's right, this is saying take 120 of whatever, say 120 cookies, and divide each in half. Well, you're going to get a lot of half of cookies, aren't you? The value should increase. So, what did we forget? We forgot stay, inverse operation, reciprocal. Oops. Remember, you can't divide by a fraction. You have to end up multiplying and using the reciprocal. So remember, if you got that part wrong today, make sure you're going back, looking, and studying it. All right, guys? Have a great day.